Have you ever wondered why the universe refuses to sit still? Why the stars, instead of staying fixed like jewels in a crown, seem to drift apart? And stranger still, how can empty space itself stretch as if it were alive? Tonight, let's take a journey across the vastness, not to chase galaxies, but to feel how the fabric beneath them quietly grows. Imagine the night sky above you as more than just a ceiling of stars. Imagine it as something breathing, inhaling, exhaling, expanding softly in every direction. Before we begin, take a slow breath yourself. Settle into your pillow. Let your thoughts drift loose like distant clouds. If this gentle voyage into the cosmos helps you feel calm, remember to press like, subscribe to The Thoughtful Night, and tell me in the comments where in the world you're listening from. Your corner of Earth, your little patch of sky, is part of this unfolding story. For centuries, we thought the heavens were unchanging, a still dome of light. But the universe had secrets. In the last 100 years, astronomers noticed something astonishing. Galaxies weren't merely moving through space. Space itself was growing between them. Like dots on a balloon as it inflates, every island of stars drifts farther from every other. The deeper we looked into the night, the more clearly we saw this quiet expansion. What does it mean for space, empty, silent space, to grow? Is it stretching into something? Or is it simply creating more of itself, endlessly, without needing an edge or a destination? These questions sound almost poetic, yet they rest on hard, careful science, on measurements of light, on the whispers of ancient radiation, on the faint signals of a universe that began 13.8 billion years ago and hasn't stopped unfolding since. Tonight, I'll guide you through this cosmic mystery with a pace as slow as starlight crossing the void. We'll wander through the clues astronomers found, meet the strange force called dark energy that accelerates expansion, and imagine the distant future when most of the stars we see today will have drifted far beyond our sight. But this isn't just a science lesson. This is a lullaby sung by the universe itself. Every galaxy, every cluster, every glowing thread of the cosmic web moves in rhythm with an unseen breath, and you are part of that rhythm. As you listen, let the facts mingle with wonder. Let the numbers dissolve into awe. You don't need to remember every detail. You only need to feel the immensity of it all, and how it somehow feels gentle. So close your eyes if you like, and let's begin at the beginning, before the first atoms, before the first stars, when the universe itself was smaller than a pearl, yet already reaching outward, already expanding. Long before telescopes, long before the language of physics, human beings gazed upward and believed they were seeing perfection itself. The heavens appeared flawless, a ceiling of brilliant points arranged with divine order, unchanging from one generation to the next. If you had asked an ancient stargazer whether the stars were moving, they might have smiled at such a notion. Of course not. The sky was eternal, steady as stone. For the early Greeks, the universe was a set of nested spheres, each turning with silent precision around Earth. Stars were thought to be fixed jewels, embedded in a crystalline shell, circling endlessly in perfect harmony. Babylonian priests tracked the paths of planets across the night, but even they imagined those wandering lights riding on invisible wheels, part of a grand cosmic machine that never wore down. The heavens seemed immune to change, too pure, too distant to share the restlessness of Earth. In those days, movement in the sky meant danger or divine will. A sudden comet was not a natural event. It was a warning. A blood-red eclipse wasn't a shadow in space. It was the anger of gods. But the stars, the steady, faithful stars, were different. They kept their places night after night. You could draw maps of their positions, and those maps would hold true for centuries. This stillness comforted people. It suggested that the universe had been made complete from the beginning, with no birth, no decay, no end. Philosophers such as Aristotle declared the cosmos to be eternal. Time itself, they thought, was endless both forward and backward, and so was the universe. To them, change was something that belonged to the earth, where trees grew and died, where cities rose and crumbled, but not to the stars, which occupied a perfect, incorruptible realm. Even when Copernicus and Galileo came along to rearrange the solar system, shifting Earth out of the center and letting planets circle the sun, the deeper universe still seemed stable. The stars appeared so fixed that early astronomers assumed they were infinitely far away, painted on an immutable backdrop. Yet small clues were already whispering otherwise. Tycho Brahe, the meticulous Danish observer of the 16th century, saw a new star blaze forth where nothing had been before, a supernova. The heavens were not immune to birth and death after all. Still, such events were rare enough to be dismissed as anomalies, not evidence of a living, changing cosmos. It took centuries for this quiet assumption to unravel. As telescopes improved, faint smudges appeared in the sky, mysterious nebulae that didn't behave like ordinary stars. No one was sure what they were. Some believed they were clouds of gas within our own Milky Way. Others suspected they might be island universes, entire galaxies far beyond our own. But even then, no one imagined that these hazy spirals were racing away, nor that the very fabric of space between them was stretching. The night sky looked calm, like painted glass. Yet that glass was already cracking, so subtly that no one could hear the sound. The modern shock came in the 20th century. Astronomers studying those faint nebulae began to notice something strange in their light. It was shifted toward the red end of the spectrum, as if the waves of starlight had been stretched during their journey. This wasn't the behavior of objects at rest. It hinted at motion, a recession. But motion through what? If the stars and galaxies were receding, they weren't simply flying through empty space like sparks from a fire. Something deeper was happening. Something that would overturn 20 centuries of cosmic certainty. Before that realization, scientists still clung to the idea of a static universe. Even Albert Einstein, when he first developed his general theory of relativity, assumed the cosmos must be balanced and unmoving. To make his equations match this belief, he added what he called a cosmological constant, a kind of mathematical fudge factor to hold the universe steady. It seemed impossible to him that all of existence could be expanding or contracting. Like Aristotle before him, he pictured a cosmos that had always been as it was, vast, serene, and eternal. But the universe was not serene. The universe was restless, and evidence was about to pour in. When American astronomer Vesto Slipher measured the light of distant spiral nebulae, he found that nearly all of them were redshifted, sliding away from us. Then, not long after, Edwin Hubble would map those shifts and show they weren't random at all. The farther a galaxy appeared, the faster it receded. Something immense and universal was at work. In that single discovery, the ancient vision of a motionless sky was shattered. The heavens were not a polished dome over our heads. They were a vast ocean, swelling and stretching in every direction. Imagine standing on a dark shore and watching distant lanterns drift away, not because they are sailing themselves, but because the water beneath them is rising, carrying them apart. The universe is like that sea, invisible yet real, pulling everything outward. For the first time, humanity had to face an unsettling truth. The cosmos was not fixed. It had a history. It had a beginning. And if it was changing now, then it would keep changing forever. This realization didn't come with thunder or alarm. It arrived quietly, through careful observation, through numbers written in notebooks. But its meaning was profound. The stars overhead, once thought eternal and still, were part of a living universe. One that grows, evolves, and carries every galaxy along in a grand, silent drift. The question remained, what does it mean for the universe itself to expand? How could empty space grow, as if it were alive? To understand, we must follow Edwin Hubble up Mount Wilson in the 1920s, where his giant telescope first opened a new window on the cosmos, a window that looked out not on a static firmament but on an ever-widening horizon. And from that vantage point, we begin to see the universe not as frozen glass, but as something soft, something that breathes. In the clear air above Los Angeles, on the slopes of Mount Wilson in the 1920s, a tall telescope waited like an unblinking eye. It was here that Edwin Hubble, an astronomer with the manner of a lawyer and the patience of a poet, began to measure the universe. Night after night, he pointed the 100-inch Hooker telescope toward faint, smudged spirals in the sky, nebulae so distant they looked no brighter than a moth's wing brushing the glass of an old lantern. What he saw would change everything. Through that powerful instrument, Hubble was able to distinguish individual stars in these nebulae, stars whose brightness could serve as cosmic mile markers. By comparing how bright they appeared to how bright they truly were, he calculated distances far beyond anything previously imagined. These spirals were not clouds inside our own galaxy. They were entire galaxies themselves, vast cities of stars millions of light years away. But the deeper revelation came when he studied their light more carefully. The spectra, those delicate fingerprints of starlight, were shifted toward the red end. This wasn't a subtle quirk. It was consistent, clear, and profound. Just as the sound of a retreating train drops to a lower pitch, light waves stretch when their source moves away. Astronomers call this redshift. And nearly every galaxy Hubble measured showed it. The galaxies were receding, not drifting a little, not meandering randomly. The more distant they were, the faster they moved away. Hubble plotted this data in 1929 and found a remarkable relationship. Distance and speed marched hand in hand. The farther a galaxy lay from Earth, the greater its redshift, and therefore the faster it appeared to recede. This was no local motion, no mere shuffle of stars in our cosmic neighborhood. It was universal. The entire fabric of the cosmos seemed to be stretching. Imagine dots painted on the surface of an inflating balloon. As the balloon expands, every dot drifts away from every other dot. No single dot is the center of the expansion. The surface itself is growing, carrying them apart. Hubble's diagram, simple lines on a simple graph, told us that our universe behaves like that balloon. Space itself is expanding, and the galaxies are passengers on this invisible tide. At first, the idea met resistance. Even Einstein, visiting Hubble in California, had trouble believing it. Einstein's own equations of general relativity already hinted that the universe couldn't remain perfectly static. Gravity would tend to make it contract or expand, but he had dismissed that implication as absurd. To keep the cosmos balanced and still, he had inserted an artificial cosmological constant, a mathematical push to counteract gravity's pull. When Hubble presented his findings, Einstein is said to have called his earlier assumption his greatest blunder. The universe was not balanced. It was not still. It was moving everywhere at once. Hubble's discovery marked the dawn of modern cosmology. No longer could we imagine the heavens as a fixed stage on which celestial actors played out their parts. The stage itself was alive, growing larger with each passing moment. For the first time, scientists understood that the universe had a history. If space is expanding now, it must have been smaller in the past. If you rewind cosmic time far enough, galaxies draw closer and closer until they meet in a brilliant, compressed state, a moment of unimaginable density and heat. This insight laid the groundwork for what would later be called the Big Bang. Not an explosion in space, but an explosion of space itself. Yet in those early days, the term Big Bang hadn't been coined, and even Hubble himself avoided speculation about cosmic origins. He confined himself to what could be measured, the speed, the distance, the steady outward flow. Still, the implications were clear. The universe is not eternal and unchanging. It had a beginning, and it is still unfolding. In poetic terms, the cosmos is not a silent cathedral of fixed pillars, but a vast balloon quietly inflating. And like lanterns painted on that balloon's surface, galaxies drift apart without ever moving through space on their own. It is space itself that grows, carrying them like passengers on a gently swelling tide. This simple yet profound shift in perspective explains why no single galaxy is the center of it all. No matter where you stand in the universe, you see every distant galaxy receding from you. Just as every raisin in a rising loaf of bread sees all the others moving away, so too does every galaxy witness the same grand expansion. What Hubble's work revealed was not just motion, it was the very breathing of the universe. And once we understood that breath, we could begin to measure its rhythm. Later refinements would allow astronomers to calculate the rate of expansion, now known as the Hubble constant. It tells us how fast the universe stretches per unit of distance. It gives us a cosmic clock, a way to trace the age of all that exists. Think of it. By looking at faint, distant light, by noticing tiny shifts in color, humanity learned that the entire cosmos is alive with motion. The night sky may look still to our eyes, but to a sensitive instrument, it is in constant flight. Galaxies as massive as 100 billion suns recede from each other without sound or wind, carried apart by the deep, invisible growth of space itself. As you picture this, let your thoughts slow. Imagine yourself floating among these distant spirals, watching them drift like glowing petals on an infinite pond. There is no rush, no hurry, only the steady, quiet stretching of reality. The same expansion that moves galaxies also passes through you, through Earth, through every atom and molecule. It is not something happening out there. It is the nature of the universe itself. From Mount Wilson's thin air, Hubble showed us the daylight of discovery. The moment when an ancient, static cosmos gave way to a living, expanding one. This revelation did more than shake astronomy. It shifted humanity's place in the story of everything. What we learned next was even stranger. Not only is the universe expanding, it is expanding faster than anyone expected. Something unseen, something mysterious, is pushing it apart with gentle but relentless force. To meet that mysterious architect, we must journey deeper, beyond Hubble's time, into the closing years of the 20th century, when another surprise waited in the stars. But before we go there, let's pause. Feel the quiet grandeur of what Hubble found. The universe is not a silent cathedral. It is a balloon slowly inflating under a sky without edges. And you, listening now, are part of that breath. Picture yourself adrift in the quiet darkness between galaxies. No engines, no movement of your own, just the calm black ocean of space. If you could somehow remain there for millions of years, you would notice something extraordinary. The galaxies around you would appear to drift apart, not because they were flying through the void, but because the void itself was swelling. This is the heart of cosmic expansion. It isn't a wind that blows galaxies away. It isn't a tide that pulls them apart. It's the fabric of space itself, stretching gently everywhere at once. To understand this, imagine dots on the surface of an inflating balloon. From the perspective of any single dot, every other dot seems to move away. There's no center on the surface, no privileged spot from which the expansion begins. The balloon simply grows, and with it, the distances between all points increase. In 3 dimensions, our universe behaves like that balloon's surface, only far grander and without an outside to expand into. Or picture a loaf of bread rising in the oven, raisins embedded within. As the dough swells, each raisin sees all the others recede. The raisins themselves don't crawl through the dough. They are carried apart as the dough expands. In the same way, galaxies don't streak through space like bullets. They are nearly stationary in their own neighborhoods, bound to their clusters by gravity, while the cosmic dough of space-time stretches between them. What does it mean for space to stretch? It's tempting to imagine space as a material fabric, like rubber, but it's subtler than that. Space isn't made of anything tangible. It's the set of distances, the geometry itself. When we say the universe expands, we mean that the yardsticks we use to measure far-off galaxies keep growing longer. 1,000,000 light-years today will become 2,000,000 light-years tomorrow, not because anyone moves, but because the very definition of distance has changed. Even light feels this stretch. As space grows, the waves of light traveling through it are pulled longer, their color shifting toward the red. This cosmic redshift is the universe's signature, telling us how far light has traveled and how much space has grown during its journey. When we observe distant galaxies, we are also looking back in time, because light takes billions of years to reach us. In that time, the universe has expanded, and the starlight arrives not as it was emitted, but as it has been gently unraveled by the journey. This is why astronomers speak of the cosmos breathing. It isn't a literal breath, but an expansion so smooth and uniform that it resembles the rhythm of life. No single region of space drives this growth. It happens everywhere, in all directions, with no center and no edge. If you tried to find the place from which the expansion began, you'd find it in every direction at once, because the Big Bang wasn't an explosion from a single point into surrounding emptiness. It was the simultaneous birth of space itself, filling every corner equally. Galaxies are not dragged along by a cosmic current. They are carried passively as the current itself forms beneath them. Between clusters of galaxies, where gravity cannot hold things together, the distances grow. Within galaxies, stars remain bound by their own mutual pull. That's why the Milky Way does not expand even though the universe does. The cosmic growth shows itself only on enormous scales, across the vast reaches where gravity grows weak. Close your eyes for a moment and imagine the night sky as a great, silent lantern dome above you. It looks fixed, changeless. Yet underneath that stillness, every galaxy drifts away from every other, carried on a tide you cannot feel. The entire stage of existence is enlarging. This is not motion through space, but motion of space. The rate of this expansion is measured by the Hubble constant, the cosmic metronome that tells us how quickly distances grow per million light-years. By studying distant galaxies and the ancient afterglow of the Big Bang, scientists have refined this value with ever greater precision. Yet even now, different measurements disagree slightly, hinting at mysteries still hidden in the cosmos. What matters most for our understanding is the principle itself. The universe is not static. It is dynamic, elastic, alive with geometry that changes over time. Where there was once a tightly packed sea of matter and light, there is now a vast, mostly empty darkness sprinkled with islands of stars. And with each passing moment, those islands drift farther apart. This expansion is not slowing down the way you might expect if gravity were the only force at work. Instead, as we'll see in the next chapter, some unknown energy seems to be pushing it faster, like a quiet wind at the edge of nothingness. But even before that discovery, the concept of a breathing universe was revolutionary. It meant that everything we see today, every cluster, every strand of the cosmic web, emerged from a denser, hotter past. It meant that the universe had an origin, a first moment, a dawn. Allow this idea to settle over you like starlight. Space itself is not a fixed stage on which events play out. It is part of the event. It evolves. It carries galaxies as easily as the tide carries leaves on a pond. Feel the wonder of that. You are not standing outside this expansion watching it from afar. It moves through you as well, though you cannot feel it. The atoms of your body remain tightly bound. Your feet rest firmly on Earth. Yet on the grandest scale, everything around you, every galaxy, every cluster, drifts apart in perfect silence. The universe does not need to push on anything to grow. It simply grows. In the next chapter, we'll travel backward through time, toward that first, brilliant instant when the universe was not yet full of galaxies or stars, only light and heat and a promise. We'll listen for the faint echo of its birth, still ringing in the darkness, the cosmic whisper that tells us how everything began. For now, let your thoughts float as if they were galaxies, gently carried by a current you cannot see. Imagine the universe inhaling, expanding softly, and know that this breath has never stopped. The night around you feels deeper now, as though the stars are not only shining above but also whispering a memory older than themselves. You close your eyes and picture the universe not as a silent void, but as something alive, pulsing, glowing, speaking in the language of light. And somewhere in that darkness you hear it. A faint hum, a glow so gentle it's almost shy. This is not imagination. It's the universe itself remembering its birth. More than 13 billion years ago, before there were galaxies, before there were stars, before there was even darkness as we know it, the cosmos was young, only about 380,000 years old. In cosmic terms, still a newborn. And newborns cry out. The universe was no different. Its cry was not made of sound but of light, a brilliant white-hot radiance filling every corner of existence. But as the universe expanded, that fiery cry stretched and softened, cooling from white to orange, from orange to red, from red to a deep, invisible whisper of microwave light. Today, that whisper still reaches us, everywhere and always. It's called the cosmic microwave background, a fragile glow from a time when the universe first became transparent. If you could tune an old television to an empty channel, a tiny fraction of the static would be this ancient light, still arriving after nearly 14 billion years of travel. The afterglow of creation, hiding in plain sight. Imagine standing on a hill at dawn, watching the first rays of sun wash over the earth. That softening light is nothing compared to the daybreak of the cosmos. Before this dawn, the universe was a fog, a glowing soup of particles colliding too quickly to form anything stable. Photons, particles of light, couldn't travel freely. They were constantly scattered, trapped in the density of matter. But as the universe stretched and cooled, particles slowed down just enough to let light slip free. That was the moment of cosmic sunrise. The light that escaped then has been on the move ever since. Astronomers, armed with sensitive instruments and careful patience, have mapped this ancient light. What they see is astonishing. Not uniform, not flawless, but speckled with tiny ripples. These are not imperfections. They are clues. They are fingerprints left by the universe's earliest moments, slight differences in temperature and density that would later grow into everything, into stars, into galaxies, into the very atoms of your body. The cosmic microwave background is more than a photograph of infancy. It's a record of breath, a trace of the first expansion. Like tree rings tell the story of seasons, this glow tells the story of space itself growing roomier. By studying its patterns, scientists have measured how fast the universe once grew, and how its expansion continues even now. But what is truly wondrous is not only what we learn, but what we feel when we think of it. Every direction you look, no matter where you are in the cosmos, you will see the same light. It is the most democratic thing in existence. It falls equally on every world, every star, every galaxy. No one place is closer to the beginning than another. The universe does not have a center. It grows everywhere at once. We are all floating in the same vast sunrise. Close your eyes again and imagine what it means. Somewhere beyond imagination, the first atoms of hydrogen and helium drift apart as the early cosmos exhales. A universe that once could have fit inside your living room is now stretching faster than any wind. And yet, it leaves behind this fragile glow, a note in a bottle traveling through time. I was here. I began. I am still growing. Even the darkness you see tonight is not empty. It is rich with this invisible warmth, faint but steady, like embers in the hearth of creation. Sensitive satellites like COBE, WMAP, and Planck have measured these embers with exquisite precision. They have traced the universe's shape, its age, its destiny, all from this soft light still washing over us. When scientists look at these ripples, they are not just seeing numbers. They are hearing the heartbeat of the cosmos at 380,000 years old. And what they hear is expansion. Not a quiet drifting apart, but a bold unfolding. Space itself has been swelling ever since this fiery dawn, carrying galaxies farther and farther from each other like boats on a rising tide. We do not simply look back at this light. We stand inside it. It passes through you even now, while you lie here in the stillness of night, carried by photons older than any star in the sky. Pause for a moment and feel the wonder of that. The atoms in your breath were once mingled in that early fire. The warmth in your body echoes the warmth of that primeval glow. In a way, you are not only in the universe, you are part of its first sunrise, still unfolding across time. But this light raises a question, one so subtle and profound it puzzled even the sharpest minds. If the universe began with such energy, what keeps it expanding now? Why doesn't gravity pull it all back together? These ancient photons tell us the universe is growing, but not why it refuses to stop. Something unseen seems to be helping it along, a quiet hand accelerating the outward breath of space. As you drift deeper into this cosmic meditation, hold that thought gently. The fiery dawn showed us that the universe was born expanding. But later, we would discover something even stranger, that instead of slowing down under gravity, the expansion is speeding up. And whatever drives it, we call it dark energy. Let's follow that mystery next, as if walking from dawn into the wide morning sky, to see what force hides in the deep fabric of space. You settle deeper into your pillow, as though you too are floating in the vastness between galaxies. Imagine a night sky untouched by city lights, a dome of stars stretched so far that your mind almost resists the scale. For most of human history, we imagined the heavens as eternal, static, a clockwork dome that ticked with perfect regularity. Even after Hubble's discovery that the universe is expanding, astronomers thought this cosmic motion would gradually slow. Gravity, they reasoned, should pull everything back, should try to stitch the seams of spacetime together again. But then came the 1990s, and a discovery that shook even the calm of the stars. Astronomers studying distant supernovae, colossal stellar explosions, like cosmic lighthouses blinking in the darkness, expected to find a universe easing its pace, coasting on the leftover momentum of the Big Bang. Instead, they found something impossible. The universe wasn't slowing down at all. It was speeding up. Pause and let that drift through you. Not just expanding, accelerating. Imagine tossing a ball into the air and watching it fall upward, faster and faster, as if pulled by an invisible hand. Something unseen is at work. Something pushing galaxies apart more strongly than gravity can pull them together. They called it dark energy. No one knows what it is. It isn't made of atoms. It isn't like light. It doesn't clump or gather. It is smooth, everywhere at once, humming in silence, an energy woven into the very fabric of space. Instead of letting the universe slow and settle, it whispers for it to grow ever faster, as though the cosmos itself cannot stop taking deep breaths. In simple terms, imagine space as a stretchy fabric. If it were only elastic, you'd expect the pull of mass and gravity to resist its stretching. But dark energy is like a hidden tailor, quietly adding more and more fabric between every galaxy, and it doesn't seem to tire. Wherever you look, it's there not as a thing within space but as a property of space itself. Astronomers estimate that dark energy makes up about 70% of the universe. 7 parts out of 10, a quiet majority of reality that we cannot touch, cannot see, cannot bottle in a lab. Matter, the stuff of planets, people, and stars, is just a small minority. Even dark matter, the invisible glue holding galaxies together, is less dominant. This mysterious dark energy is the true conductor of the cosmic symphony, guiding how everything spreads apart. And yet, it is profoundly gentle. If you were floating in the emptiness between galaxies, you wouldn't feel any push or wind. It doesn't shove, it doesn't roar. Over billions of years, its effect is relentless. Not dramatic like an explosion, but steady like the tide, drawing every distant shore further and further from our own. Think of it poetically. Something unseen holds the strings, urging galaxies apart ever faster. A quiet architect building rooms in an endless house. A breath that never exhales. In 1998, when teams of scientists confirmed this acceleration, many resisted believing it. It seemed too strange. But the data were clear. Those supernovae were dimmer than they should have been, farther away than gravity's tug alone could explain. Something was stretching the universe more quickly than anyone expected. And the more we measure, the more consistent the picture becomes. The cosmic expansion is not just ongoing, it is speeding up. What is this dark energy? Is it a property of empty space itself, what Einstein once called a cosmological constant, a built-in pressure that space naturally exerts? Or is it some dynamic field, changing over time, something we haven't even begun to glimpse? Could it someday fade away, or grow stronger? No one yet knows. But the universe keeps whispering its answer in light from distant galaxies. Every telescope that peers deeper into time, every map of cosmic microwave background ripples, every measurement of galaxy clustering, all speak with one voice. Acceleration is real. Let this thought carry you. Space is not a hollow nothing. It is alive with this subtle energy, a presence that fills every corner. It does not glow. It does not cast shadows. But it holds the destiny of the cosmos in its invisible hand. As you imagine yourself drifting among the galaxies, picture them like lanterns on an ocean. The waters are not calm. They rise between the lanterns, quietly widening the distance. You, a passenger on one small raft called Earth, feel none of this motion directly, yet the currents are there. Over billions of years, they will scatter these lanterns until only a few remain visible to one another. Dark energy writes this future. It shapes the chapters yet to come. And in its mystery, there is wonder. The universe is not winding down into stillness. It is alive, growing, restless in its expansion. You are part of that story. Every atom in your body, every breath you take, belongs to a cosmos that is still unfolding, still making space where there was none. If you could listen to the universe not with your ears, but with your heart, perhaps you would hear that quiet architect at work, stretching, expanding, guiding. And now, let the thought settle softly. The universe is not slowing. It will not fall back on itself. Something unseen holds it open, wide as eternity. As we drift onward, we ask, if the cosmos is expanding forever, what does that mean for its shape, for its ultimate fate? What does it mean for space itself to grow? Not just the stars moving apart, but the very fabric beneath them stretching, like an invisible tide that rises without a shore. The question lingers in the darkness. If the universe keeps expanding, what shape does forever take? Astronomers once imagined 3 simple possibilities, each painted with the brushstrokes of geometry. Think of space as a canvas, not flat like paper, but a deeper kind of shape, one that only reveals itself when you look far enough. The first possibility is a closed universe, curved inward like the surface of a sphere. In such a cosmos, if you traveled far enough in a straight line, you would return to where you began. Expansion might one day slow, stop, and reverse, like a deep breath exhaled and then inhaled again. A universe that ends not in fire, but in collapse, a big crunch. The second is an open universe, curved outward like a saddle. In this version of reality, expansion goes on forever, thinning and fading without end, galaxies drifting apart into eternal night. There would be no edge, no boundary, only an ever-cooling emptiness. And the third is a flat universe, balanced on the knife edge between the two. In a flat cosmos, expansion never quite stops, yet never tears apart at impossible speed. It coasts forever, slower and slower, yet always moving outward. Which vision matches the one we live in? The answer came not from imagination, but from measurement. Astronomers mapped the cosmic microwave background, the faint afterglow of the Big Bang, still shimmering across the entire sky. They traced how light bends around massive clusters of galaxies, using gravity itself as a lens. And with every observation, the evidence whispered the same truth. Our universe is remarkably flat. But this is not flat like a table. It's flat in a deeper sense, one only geometry can describe, where the angles of a great triangle add up just as they do on a piece of paper. A cosmic balance, precise almost beyond belief. What does this mean for the future? A flat universe should expand forever, coasting outward as its energy thins. Yet when scientists looked closer, they found something stranger. The expansion wasn't slowing at all. It was speeding up. A mysterious pressure, now called dark energy, is pulling galaxies apart faster than gravity can hold them together. Picture the cosmos as a balloon, not inflated by air but by something you cannot see or touch. Each moment, the balloon stretches more quickly than the last, carrying galaxies farther away from each other, as though space itself were restless. What kind of forever does this create? If dark energy keeps its steady push, then distant galaxies will continue to slip from view, one by one, their light stretched until it fades into invisibility. The night sky will become quieter, lonelier, but not because stars burn out. It is space itself that will hide them, placing them beyond the reach of any telescope. If dark energy grows even stronger, some scientists imagine a stranger fate. A big rip, where galaxies, stars, planets, even atoms, are torn apart by relentless expansion. But if dark energy remains gentle and constant, our universe will drift outward forever, its growth accelerating but not destroying what it leaves behind. So, closed, open, or flat? The truth seems to be this. The universe is flat, but driven by an unseen energy that makes it forever not calm, but restless. Pause for a moment and imagine it. An infinite horizon, stretching outward in every direction, yet never looping back on itself. No cosmic edge, no final wall, just more space unfolding, as if creation never stopped, only slowed to a hush. What does this say about our place in it? Perhaps that we are not passengers on a static stage, but actors inside a story that's still being written. Forever is not a fixed shape, waiting to be measured like a piece of wood. It is a living geometry changing even as we watch. And as you breathe slowly in the quiet of your own room, remember, the same laws that describe your heartbeat, your breath, your life, the rhythm of time flowing forward, also describe the rhythm of the universe itself. You are not outside this expansion. You are part of it. Every atom in your body rides the same growing space. Every thought you have belongs to a cosmos that will one day be wider, darker, and quieter than you can imagine. And yet, in this stillness, there is beauty. The shape of forever is not frightening. It is open, balanced, graceful. It is a universe that does not end with a crash, but drifts gently into the deep night, carrying you, me, and every star into its unfolding story. The night sky you see tonight is a time machine. Every star, every soft smear of light from a distant galaxy, is a memory so ancient that it has traveled across oceans of space for millions, even billions of years just to reach your eyes. You are never looking at the universe as it is now, only as it once was. Imagine holding a paper lantern over a calm river. You let it go. It glides away, carried by a current you cannot see, its light becoming smaller, softer, until it is just a warm speck swallowed by the dark. This is how galaxies drift apart in an expanding universe, not by their own will, but by the quiet pull of something invisible. Space itself stretching, like a slow exhale. When astronomers look far into the cosmos, they see light stretched into deeper and deeper shades of red. This redshift is a cosmic whisper that galaxies are fleeing from us, as though every lantern on that river is drifting downstream. But unlike a river, there is no edge, no bank to stop them. Space itself is the current, and there is no upstream. If you could live not just for decades or centuries, but for trillions of years, the night sky would change in ways both wondrous and lonely. The familiar constellations would slowly distort as stars move along their own paths. Distant galaxies, now barely visible as faint smudges in telescopes, would fade entirely from view. Their light would be stretched until it no longer glows in any color human eyes can see, no longer even in the kind of light telescopes can catch. It is as if the lanterns go not only farther away, but dim out of existence, leaving only the closest companions in our cosmic neighborhood. This does not happen quickly. For countless human generations, the sky will still feel the same. But over deep time, a time so vast it is measured not in millions but in quadrillions of years, darkness will grow. The Milky Way and its sister, the Andromeda Galaxy, will have long since merged into a single immense spiral. Around us, a few small companion galaxies will remain bound together by gravity, forming an island universe. Beyond this island, space will swell faster than light can cross it, taking everything else beyond our reach. Even light can lose its way, stretched into silence. What does that mean for those who gaze up in that far future? They will live in a sky stripped of ancient clues. They may never know other galaxies existed. The cosmic expansion will have hidden its own tracks. The universe will seem small and local, even though it will be unimaginably vast. A quiet irony: the more the universe grows, the more it hides its grandeur. And yet there is a strange comfort in this slow dimming. Expansion is not an explosion that tears things apart violently. It is a soft, ceaseless drifting, like lanterns over water, never colliding, never hurried. Stars are born, live, and die inside galaxies that continue their dance even as the stage itself grows wider. Pause for a moment and picture this. Billions of glowing spirals, each a city of stars, all gliding apart in perfect silence. No wind, no sound, only the steady beat of cosmic time. This is not chaos. It is a kind of order written in motion, a pattern too large for one lifetime to see. And though our sky will one day darken, that does not make it empty of meaning. We are alive at a rare moment in cosmic history, when the universe is old enough for galaxies to form, yet young enough that we can still see them. The lanterns still shine all around us. We are witnesses to a fleeting glow, standing on the shore before the current carries the last lights beyond the horizon. So tonight, when you look at the stars, think of them not as fixed points, but as travelers. They are lanterns that have crossed a river older than time itself, their light finding you here, now. And you, too, are drifting with them, part of this vast and quiet voyage. A lantern among lanterns, floating through the dark. Picture the universe as a tapestry, a delicate lace of galaxies strung together by invisible threads of gravity. Astronomers call it the cosmic web, filaments of light and matter weaving through unimaginable darkness. Where these threads cross, clusters of galaxies gather like glowing cities at a crossroads. Between them stretch immense voids, cosmic deserts so empty they could hold entire galaxies without touching a grain of dust. For billions of years, this web has stayed intact. Gravity, the patient sculptor, has drawn matter together into shimmering strands. But as you drift forward in cosmic time, you sense a change. The expansion of the universe, gentle once, now hurried by dark energy, begins to tug at the threads. The loom of creation is loosening. It is not a tearing you can hear. There is no snap, no sudden sound. It is a slow unbraiding, like silk unraveling in silence. Galaxies within clusters still cling to one another, bound by local gravity. Yet clusters themselves, like ships loosed from anchor, drift apart on the swelling tide of space. Imagine you are floating in the middle of this web, watching epochs pass as easily as clouds. The filaments stretch, thin, and grow faint. What once looked like a rich net of jewels now resembles isolated islands glowing on an ever-deepening ocean. The cosmic shoreline recedes. You might ask, does the web truly vanish? Not completely. The threads nearest to you, stitched by gravity's tenacity, hold their form. But the farther filaments, the distant intersections of galaxies, slip beyond your sight. Their light, stretched to longer and longer wavelengths, dims into invisibility. Even the sharpest telescope of the far future would see only the local cluster, a single sparkling island marooned in dark infinity. The universe becomes archipelago instead of continent. Bridges between clusters grow so long they may as well not exist. Where once you could trace the structure of all creation like veins under skin, now the map fades. And yet, this unraveling is not chaos. It is cosmic order changing shape. Dark energy does not shred the web violently. It simply outpaces gravity's patient weaving. Matter still dances to its own music in smaller regions, forming stars and planets, life and questions. But on the grandest scales, space itself grows too swiftly for old patterns to hold. Drift further. Picture 1 trillion years passing, then 10 trillion. Whole superclusters have become lonely wanderers. If any conscious beings remain to gaze at the sky, they will not see the web. They will see only a solitary glow of nearby galaxies, unaware they were ever part of something larger. The universe will seem quiet, almost private, as if the cosmos has drawn a curtain over its earliest history. The beauty here is bittersweet. Structures that once mapped the infant cosmos, the frozen ripples of the Big Bang etched into the arrangement of galaxies, dissolve into darkness. But their story is not lost. It is written into the very expansion of space, like music held in memory after the notes have faded. You can think of it this way. The cosmic web is not dying, it is being transformed. It served as scaffolding for stars to ignite, for galaxies to grow, for planets to harbor eyes that look up and wonder. Once its purpose is fulfilled, the scaffolding can fall away. What remains is still the universe, quieter, lonelier, yet no less vast. Let your thoughts wander across this ocean of deep time. See how every glowing thread you once traced with a cosmic finger loosens, floats, and disappears into the black. Feel no fear in this. The web is not being destroyed by malice. It is simply yielding to a deeper rhythm, one that favors expansion over connection. Even here, in the farthest reaches of time, gravity refuses to surrender completely. Inside each island of light, stars continue to spin in graceful orbits, galaxies still breathe and grow, and the slow pulse of starlight still glows. Life, if it still flickers, will do so under skies that seem quiet and still, not knowing the universe was once a bustling city of galaxies shouting across space. The cosmic web unravels, but not into nothingness. It unravels into solitude, a kind of cosmic hush. And in that hush, there is room for reflection, for new beginnings no mind can yet imagine. Out in the deep silence of space, where no air carries a sound, there is still a kind of music. It does not reach your ears as a melody, nor can you hum it on your way home. It is written not in notes but in patterns, in the faint warmth of ancient light, in the arrangement of galaxies scattered like seeds in an infinite field. The universe has been playing this symphony since the very first moments of time, and it continues even now, though few ever pause to listen. Imagine standing on an empty plain at dawn. The air is cool, the horizon endless. Somewhere in that stillness, you sense a vibration, as if the earth beneath your feet remembers something. That is how astronomers first felt the music of the cosmos. Not through ears, but through instruments that could tune to the faintest whispers, the dimmest glows. This music began as fire, the hot, blinding light of the newborn universe. When space was young, it was so dense and brilliant that light itself could not travel freely. Photons bounced from particle to particle, trapped like dancers in a crowded hall. But as space expanded and cooled, these photons finally slipped free, radiating outward in all directions. They still travel now, after nearly 14 billion years, stretched into microwaves by the growing universe. Today, we call this faint glow the cosmic microwave background, a soft afterimage of creation itself. It is everywhere. Point a sensitive detector at the night sky, and no matter where you aim, you will find it. A quiet hum that fills all of space, uniform but not perfectly so. There are tiny ripples, slight variations in temperature no bigger than a few millionths of a degree. And in those ripples, the universe speaks. What do these ripples say? They tell us about the first heartbeat of everything. They reveal how matter clumped together, forming seeds that would one day become galaxies. They show how space itself swelled during a mysterious flash called inflation, when the universe grew faster than light, stretching quantum fluctuations into vast cosmic structures. This was the first movement of the cosmic symphony, a burst of unimaginable energy setting the tempo for all that would follow. Later, as galaxies formed and stars lit up, the music gained harmony. The distribution of galaxies today still follows that early pattern, like echoes repeating across cosmic time. Astronomers map these structures, great walls, filaments, and voids, and they find the same rhythm imprinted there. The notes have grown softer, stretched thin by expansion, but the melody remains. Even gravity, usually so silent, adds its voice. When massive objects collide, two black holes spiraling together, or neutron stars tearing at each other's cores, they send ripples through space itself. These ripples are gravitational waves, another instrument in the cosmic orchestra. Detectors on Earth, such as LIGO and Virgo, have only just learned to hear them. Each passing wave is like a distant drumbeat, proof that spacetime itself is alive with motion. If you close your eyes, you can imagine this orchestra, the cosmic microwave background as a soft, endless hum, the memory of the universe's birth. The galaxy patterns as deep chords, slowly shifting over billions of years. The gravitational waves as faint, distant percussion, marking cosmic collisions in time. It is not music in the human sense. It has no chorus, no refrain. And yet, it carries a profound order, a cosmic score written into the fabric of reality. Each instrument tells scientists something about how the universe expands, how matter and energy interact, and what hidden forces, dark matter and dark energy, guide this vast performance. When astronomers listen carefully, they hear more than beauty. They hear measurements. They can tell how fast the universe is growing. They can trace its history back to less than a second after the Big Bang. They can even glimpse its possible future, reading ahead in the sheet music of spacetime. And here is a thought both humbling and comforting. The very atoms in your body, the calcium in your bones, the iron in your blood, they too vibrate to this music. You are made of particles that once swam through that hot early sea, particles that felt those first cosmic ripples. You are not just an audience to this symphony. You are part of its sound. The music still plays, though its tempo changes. Dark energy accelerates the expansion, stretching the notes further apart, thinning their texture. Over immense spans of time, the cosmic hum will grow softer, more distant. Future astronomers, billions of years from now, may hear less of this ancient melody, as galaxies drift away and the background glow fades into almost nothing. But right now, in this brief cosmic moment, we can still hear it clearly if we listen. So lie back for a moment. Let the night sky be your concert hall. Imagine those first photons rushing free. Imagine space-time itself vibrating as black holes collide, sending ripples through the void. Imagine galaxies arranged like chords in a deep, endless song. This is not silence. This is the oldest music there is. And as you drift toward sleep, carry one last thought. If the universe has written such harmony into its very structure, then perhaps it writes harmony into you as well. Every heartbeat, every breath, every quiet moment of wonder. These are verses in the same cosmic hymn. And as the final notes fade, we turn to the last movement of our story. What all this expansion means for the small, bright world we call home. You are floating, still wrapped in the lingering music of an expanding universe. The faint hum left over from creation itself. The cosmic symphony fades into quiet now, but its meaning is not lost. In the stillness, a deeper question arises. What does all this mean for you? For us, here on this small world orbiting an ordinary star. It is tempting to imagine that cosmic expansion happens out there, far from human life, among galaxies we will never visit, at scales we can hardly conceive. Yet this grand growth of the universe is not something separate from you. You are made of it. Your atoms were born in stars that scattered their light into this expanding space. The breath you take now, this very moment, is part of a cosmos still unfolding, still stretching, still becoming. Astronomers once feared that an expanding universe might spell doom, that everything would grow thin, cold, and meaningless. But the truth is gentler. Expansion is not a shattering. It is a soft opening. The universe grows as life grows, not in chaos, but in rhythm. Galaxies drift apart not because they are falling away from one another in anger, but because space itself is being woven wider, like a cosmic cradle. And you live in that cradle. When you look up at the night sky, you are seeing light that left its source millions or billions of years ago. But it is still here, finding you now, crossing the growing universe to touch your eyes. That light is proof that, even as space expands, it carries connection within it. The stars are not abandoning you. They are simply part of a wider dance, and you are invited to listen. In the 1990s, scientists discovered that the universe's expansion is not slowing, as once believed, but speeding up. Something unseen, dark energy, urges galaxies apart ever faster. It sounds lonely, even frightening. An ever-growing darkness between islands of light. But remember, darkness is not an enemy. It is the quiet canvas where light is painted. Without darkness, you could not see the stars at all. So what does this mean for humanity here and now? It means that the cosmos is not a fixed backdrop. It is alive, restless, creative. It will not end soon, not in any way that touches your daily life, or even the lives of civilizations yet unborn. The timescales are so vast they dissolve fear into awe. The sun will shine for billions of years more. Earth will spin on, changing as it always has. The expansion of space is no threat to your morning coffee, your laughter, or the small joys of being human. Instead, it is a reminder that everything is connected by invisible threads, that you are not an outsider looking at the universe from afar. You are the universe aware of itself. The same expansion that carries galaxies apart also carried stardust into the cloud that formed your body. The same laws that draw maps of distant galaxy clusters also trace the heartbeat in your chest. Even as distant galaxies slip beyond sight, you remain bound to the story of all things. The atoms in your blood still hum with the memory of the Big Bang. Every cell is a tiny echo of cosmic creation, vibrating softly to the same deep rhythm that drives the galaxies. Pause and feel that. This is not a reason for sadness. It is an invitation to wonder. To live knowing that you are part of something immeasurable. The expanding universe is not racing away from you. It is unfolding through you. Your thoughts, your kindness, your questions, they are as real a part of this cosmos as the spiral arms of distant galaxies. One day, far beyond human history, the night sky may grow quieter, its lanterns dimmed as galaxies drift too far to see. But you live now in a time when the heavens are still bright, when the cosmic music is still audible. And while you cannot stop the universe from growing, you can let that truth grow inside you. Life is precious, time is vast, and curiosity is your guiding star. When you gaze into the deep darkness, remember, you are not apart from this growing universe. You are its awakening mind. You are its way of looking back at itself and whispering, "What a wonder you are." So rest now, beneath a sky still filled with light. Let the thought of an expanding cosmos lull you, not alarm you. Space stretches, galaxies drift, but wonder is constant. And in that wonder, you will always belong. The universe continues its quiet unfolding, and you, small yet luminous, are part of its song. The galaxies drift apart, yes, but not in sorrow. Their separation is only distance, not disconnection. Like lanterns released on a still night, they shine together in the same endless dark. The cosmic fabric stretches, carrying with it every star, every planet, every thought ever dreamed beneath the skies. And here you are, breathing, listening, feeling your own heart keep time with something immeasurably vast. This expansion is not a rushing toward emptiness. It is space making room for what might be. It is the cosmos reminding you that change is its nature, and yours too. When you next look at the night sky, know that its quiet light has crossed unimaginable distances to meet you. And somewhere, far beyond sight, new light is already on its way. Close your eyes. Drift into the calm of an ever-widening universe. Let its gentle silence carry you, as though you too were a lantern, glowing softly as you rise.